Welcome everybody, Wan Chan here. Today we are going to learn linear law. Alright, now the word linear means a straight line, right? So in this chapter we are going to learn how to draw straight line graphs and solve problems from there. Alright, as an introduction, okay, let's see. Now in the world of science we have to do lots of experiments, right? And when you do the experiments, you collect data. Okay, once you got a set of data, what do? We plot the graph and then we draw the line. Alright, so let's say you have a set of data already collected, let's say xy values. Then we will draw a graph and we will take all the coordinates here and we will plot the points. Okay, let's say like this. Alright, now once you have plotted the points, you put the ruler and draw a line. Now how do you draw a straight line when the points are all not in order in a straight line? So what you do, you put the ruler there and you should adjust the ruler such that you get the line of best fit. Now what is the line of best fit? Okay, let's say we got a line here. Okay, this is the line of best fit. The line of best fit is a line which must fulfill both these conditions. The first is, it must pass through as many points as possible, and the second point is, it must, all the points that do not fall on the drawn line, that means this point and this point here, they should be equally distributed on either side of the line, up and down. Okay, for example, I do this line because you have 3 points falling on the line. Okay, then you have 1 point up here, 1 point down here. So these 2 points are equally distributed. You cannot have, let's say, okay, 2 and 1 is possible, it's okay. But let's say you have 3 down and 1 up, then this is no more a line of best fit. Okay, a line of best fit means the points that fall up below and above must be almost equally distributed. Okay, so like say you have 3 and 1 is not a good line of best fit, but if you have just 2 and 1, yes, it is a line of best fit. Or you have 2 and 2, it's also okay, very good. Okay, so we are going to learn how to draw the line of best fit much later. Before that, let's go back to the title, linear law. So, why do we learn linear law? Because we want to draw a straight line. Sometimes, okay, after you draw the line, you will form equations, and from the graph, okay, once you got the graph, you can find values from the graph. Okay, so let's say your graph you have drawn up to here, okay, value of x and the value of y. Okay, let's say if I ask what is y when x is 6, right? What is y? You want to know what is y when x is 6? What is y? So what you do, from the graph you look for 6, then you will go up to the graph, maybe here, and then you will read the answer here. This will be your y. So when x is 6, you get a value for y. This means we are interpolating. You know, you want to find values within the range that you have drawn. You call the process interpolating. Okay? Or if you want to find x when y is 5. Same thing. When y is 5, you go to the graph and you go and read the value down here and you got your x value. This is all called interpolating, finding values within the range that you have drawn. Now what if I ask you, what is y when x is 12? What is y? What is y? So when you see your graph, you only have drawn up to 10. 12 is outside here. But you can still find the answer because it's a straight line. You can just extend it. The straight line can be extended, right? You can go backwards, you can go forward. So no problem, you just extend the line. Then you can read the value of y here, right? So this is called to extrapolate. To extrapolate means to find values outside the range that you have drawn. So when you have a straight line graph, there's no problem because you just have to extend the line and you can always go and read the value. Okay, but what happens if you have a curve, a non-linear graph? Can we interpolate and extrapolate? Let's say in my experiments, my scientific experiment, I got a curve for my answer like that. This is my answer, right? And you have drawn, say, up to 10. Okay, here also 10 lah, let's say, y and x. Now, if I ask you, find y when x is, let's say, 12, what is y? How are you going to do this? That means outside the limit that you've drawn, you want to find the value of y. How do we do this? Do we know where the graph is going? Is it going to go like this? Or is it going to go like this? Or how is the curve going to turn? We are not sure, right? Because it's a curve, we cannot extrapolate the graph to find values of that we want outside the range. Okay? So that is why we are learning linear law today. Linear law will teach you how to change a non-linear equation into the linear form so that the curve will become a straight line. Once you get it into a straight line, then you can extrapolate, interpolate easily. Okay, so that's the whole purpose of this chapter. Okay, we are going to learn how to change a non-linear equation into the linear form. Then we can draw a straight line, and from there we can extrapolate anytime. Okay, so today I'm going to teach you how to convert a non-linear equation into the linear form today. Okay? Convert a non-linear okay, this is what you're going to learn now. Before that, please take some note. There's this capital or we use. Okay. Use y equals to mx plus c. Okay, we're going to use the linear equation y equals to mx plus c. Everybody knows what is m? Is the gradient. And what is c? Is the y-intercept. Okay, this is a linear equation, right? Now, note that capital Y, it must consist of small y can have small x and cannot have any number. Okay, example, y squared over y log y square root y xy y over x. Okay, I'll explain soon. very important thing for you to know. So examples of capital X can be x squared or x cubed, 1 over x squared, log x, square root x, and so on. Alright, these are very important things you have to know. Okay. So in order to convert a non-linear equation to a linear form, right, you need to get the equation in the form of y equals mx plus c. Alright, what is capital Y? Capital Y must consist of small y, can consist of small x, and cannot have any number in front. You cannot have a number in front of capital Y here. Alright? Example for capital Y's could be y square, 1 over y, any form of equation with a y that can. Okay, but you cannot have a number in front. That means the coefficient in front here is cannot have lah. Alright, it's 1. Coefficient of y will be 1. Alright? Okay. Capital X, it must have consist of small x, cannot have y here. Alright, cannot have y here. And it can have a number in front because the number in front is the gradient. So this is the thing. Example of capital X will be like this: x squared, x cubed, anything in the form of small x. Okay, you know that? That means capital Y can be in the form of xy also, can have small x, but capital X cannot have y in it. So these are examples. Alright? Okay, now we go on. I'll teach you the technique how to convert a non-linear to the linear form. You must remember this. Okay. Okay, now let's see how. Example. Example 1. Y cubed equals to, say, 3x squared plus 5, right? Now this equation is a non-linear equation. How do I change it to the linear form? I want to change it to y equals to mx plus c, that form. Okay, when you look at it here, this looks like capital Y, no problem. This could be capital X, but then you have x here and x here. So you cannot have two places x. It's mx plus c only. C is alone. It's a number. So you cannot have x here and x here. So therefore you need to get rid of one of these. Okay, what you can do? Well, I could divide all by x so that this one disappears. Or I could also divide all by x squared. Then this will disappear. You can do anything. Okay? Doesn't matter, both also accepted. Okay, let's say I divide all by x, so I'll get y cubed over x equals 3x plus 5, right? So now in this case, you can identify already. This is going to be my capital Y. See, capital Y can consist of small y, small x, no problem. And this is your capital X here now. So what is the number in front of it? It is the gradient. And what is this number behind? It is the C. Okay, this is capital Y, this is capital X, this is your M, and this is your C. That's all you need to do. Okay, you need to identify. So later on, when you draw a graph, instead of plotting X against Y, because you're going to get a curve, what you do, you're going to plot capital X against capital Y. Which means here is small x against y cubed over x. You need to find all the coordinates for this, and then we plot this graph and you will get a straight line. Okay, so that's why we are doing this. Alright, now I'll give you some more examples. I'll give you many examples. Okay, how about this? Example 2, y equals to hx plus k over x. Now h and k are just numbers. I can put numbers like this, or I put alphabet, doesn't matter. Okay, this is a non-linear because we have x here, we also have x here, right? So cannot. We must get it into this form, y equals to mx plus c. So what shall I do? I know I have to get rid of one of these. So what I do, I can times out by x here. So it means you times everything by x. So here you get xy, here you get hx squared plus k. Okay, so then it's done. This is your capital Y, which is okay. This is your capital X, which is x squared. Therefore, what is this? What is in front of x? The gradient, mx. So h is the gradient. And what's the value behind here? Is the y-intercept, which is the value of c. Okay, you can identify everything here once you change. Okay, let's see some more examples. Number 3. How about y equals to h root x plus k over root x? What should I do here? Again, we see there's x here, there's x here. We have to get rid of one of them. So I will probably have to times with root x. Then we'll get y root x this side. Here, what happens here? What is root x times root x? It means root x squared, right? So the square and the power, the root will cancel off. So you are left with just plain x. So here, root x times root x will be just plain x. You get it? Plus k. Okay, so that's your answer. So now we identify this is my capital Y and this will be capital X. So what is this? This is the M and this is the value of C. Okay, Y equals to mx plus C. Alright, now let's look at the next one, number 4. Let's say, what if you have y and 4 equals to hk power x. Okay, how are we going to make this into the linear form? In linear form is y equals to mx plus c. So this one has to be separated. How to separate this? The only way is to log both sides. Okay, so we do log y equals to log hk power x, right? Now when you log both sides, then you expand this one, use the law of logarithm, becomes plus log k power x. Then finally, so here is log y. Finally, this power, using the law of logarithm, can be put in front. So it becomes x log k. Okay, so I cancel off the power. Okay, so done. So now you have already got it in the form of y equals mx plus c. We identify this is capital Y because it has the y in it. Where's your capital X? We must have the small x. So when you look here, it's here. This is your capital X. Just the x alone. What is this then? What is the number beside the x? It has to be the gradient mx. So this one will be the value of c. So you have y equals mx plus c. It's the same thing, okay? Just arrange differently. So you have to be able to identify the x. Okay, sometimes if this symbol is a minus, if not for example, if this were a minus, then your gradient will be negative log k. The negative will follow the number. Okay, the capital X will be this only. The gradient will be negative log k. Remember, if the number symbol in front is negative, it follows the number here. So m will be negative log k. Right? But not now lah. For this question, it's the plus. So it is actually positive log k, your gradient. Okay, let me wrap this off and show you some more examples. Hope you are getting it. How to change a non-linear to a linear form. Okay, so this is step 1 what we learned today. Next lesson I will show you how to apply what you learned to do the questions. Alright? Today we learned only this, how to convert one to the other. Okay. Let's do one more. Example 5. Let's say y is equals to h over k minus x. Okay, what are we going to do here? How do we separate this? We want to get in form of y equals to mx plus c separated. How can we separate this? It's impossible, right? You can't do this over this and this over this for this. The denominator has to be up, then you can do it. So what we do, we switch both sides, we reciprocal both sides first. 1 over y equals to k minus x over h. We turn them both, we flip them both upside down because now I can separate this and this. These two can be separated. So we get 1 over y equals to k over h minus x over h. You see that? Because we do reciprocal, because this way you cannot separate. So what you do, we turn it over, flip it over. So we got this. And now this can be separated because same denominator, we can separate them. And we can identify already. This is my capital Y. Where's my capital X? Then this is your X, alright? Now negative, the H is down, you can actually write it in front like this. 1 over H, instead of putting it there, you bring it in front. So you are left with like this. This is a number. So this is your capital X. So what's your gradient? This is your gradient. Negative 1 over H. Okay? I should write the M there. This is your M. This is the M. Because it's next to the X. Whatever is beside the X is M. And this will become your C. So it's like that. Y equals to mx plus c. You notice? Okay? The h which was down here, I bring it in front. So it's actually negative 1 over h. Okay, that's the coefficient of x here. So this is how you do this one. Alright, some more. Let's say this one. Number 6, 1 over y, or maybe we put a number there, h over y equals to say k over x plus 1, right? Now do we have this in the form of y equals to mx plus c already? Y equals to mx plus c, can or not? Something is wrong. Remember, in front of y, you cannot have number. So this number is not supposed to be there. This is actually like this. You see, I bring the h in front. It's actually like this. And capital Y cannot have a number in front. It shouldn't have a number in front. So we need to get rid of the number in front. So what do? We don't want the h. So we divide all by h. Okay? So this is what I'm going to do. I'm going to divide all by h. Okay, divide by h. So divide by h, the h will cancel off, we are left with 1 over y. This side, we divide by h, we get k over h and x plus 1 over h. Everything divided by h. Because we want to get rid of the number in front of the capital Y. This is not one condition, okay? In front of capital Y cannot have anything. Alright, now you're done. So this is capital Y. Where's the capital X? Now x is down here, it means 1 over x is your capital X, like this. This is your capital X, 1 over x. And what is this one here, k and h? This is your gradient, mx. And what is this one here? Plus the c. You see that? 1 over x is a capital X is 1 over x, gradient is k over h. Just move it in front. Okay? So that's how you do this question. Okay, is that okay, or do you want some more examples? Maybe another 2 more examples. Alright. Hope you're getting it. Now, there are more than one way of doing this. So you may do something, your friend may do something else, but both may be right. Okay? Doesn't mean there's only one way. For example, 7 is it? Example 7, let's say we do h x power k. Okay, what do we do here? How do we separate this? We need to do what? We need to log both sides. Okay, so we do log y equals to log h x power k, and this will be further broken up into log h plus k log x. You know the k has come from up here to the front. And this is law of logarithm. Okay? So that's done. Now we can identify capital Y. Where's your capital X? Here, right? So log x is your capital X. Therefore, what is this one? This is your M. And this will be your C. Okay? Y equals mx plus c. Easy? You get it? Alright? Okay then, I think that should be fine. Okay, we will do questions in your next episode. So for now, you need to practice how to change an equation, non-linear equation to the linear form. Thanks for listening. Hope you understand and hope you enjoy your maths. Bye.